For the Exam 5-2 video, I selected prompt A. For my experiment, I will be improving my goldfish population by breeding for larger fish. In order to get bigger fish, the top 10% with the highest weight will be used. The heritability values for goldfish weight are 0.85 for broad sense heritability and 0.67 for narrow sense heritability or realized heritability. The distribution for goldfish weight follows a normal distribution with a standard deviation of 1 ounce. The initial population mean weight for my original population is 7 ounces. In order to know which fish I will be selecting, I need to know what the truncation point is. When a percentage of a population is selected, the truncation point is the value at which you will begin to select your individuals from. In this case, the truncation point will be the lowest weight at which I will select my fish in order to only use the top 10%. The formula to calculate this value is x sub t, which is the truncation point, equals mu, the initial population mean, plus z times sigma, where z is the standardized selection point and sigma is the standard deviation. The value for z is located in the standardized table and is determined based on the proportion of population selected, which in this case is 0.1, leaving z to equal 1.282. Plugging the numbers into the formula, the truncation point equals 8.282. To calculate the mean of the selected parents, I will need to calculate the selection differential, which is the difference between the mean of the selected parents and the initial population mean. The formula for selection differential is S equals I times sigma, where I is the selection intensity and sigma is the standard deviation. The value for I is located in the same standardized table as the standardized selection point. For my experiment, the value of I is 1.755. Plugging the numbers into the formula, the selection differential equals 1.755. Using this value, I can calculate the mean of the selected parents by adding the initial mean population and determine that x sub s equals 8.755. Lastly, to determine the mean of my new offspring population, I will need to calculate the response from selection, which is the difference between the mean of the offspring and the initial population mean. The formula for response to selection is R equals the narrow sense heritability times the selection differential. Plugging these values in gives a response to selection value of 1.176. Using the response to selection value, we can add this to the initial population mean to determine the mean of the next generation, which is 8.176. Looking at this histogram, we can see in the solid bell curve mu, or x sub 0, is the initial mean population. The top 10% is shaded above the truncation point, or x sub t. The mean of the selected individual is x sub s, with the difference between this mean and the initial population mean equaling s, or the selection differential. The dotted line bell curve represents the new offspring generation with a mean of x sub 1, and the difference between the mean of the offspring and the initial population equaling r, or the response to selection. While I was able to increase the average weight of my goldfish, I wouldn't be able to complete this experiment indefinitely. After a certain weight, goldfish lose their fertility and egg production decreases, and thus viable offspring would not be available.